Hello and welcome to problem set 2, expressing uncertainty. Before we get started, I do want to remind you that the problem set worksheet is available from my website, and I do recommend that you have that in front of you as we go through these problems. I will read the problems, but I won't be writing the problem on the board. I'll just be writing the solutions on the board, okay? With that said, let's go ahead and get started. All right, number 1. Express the following measurements, there's an A through C, in scientific notation and with 3 significant figures. Okay, so for A, it's already 3 significant figures, 967 centimeters. So we really just have to put this one in scientific notation. Grab your decimal. We're moving it 2 places to the left. Get a number between 1 and 10. So we get 9.67 times 10 to the 12. And it's a positive 2 because we moved the decimal to the left. We had a big number and we made it smaller. So times 10 to the 2. All right, B, 20,000 grams. Okay, so grab your decimal, move it 1, 2, 3, 4 places to the left again. So we get 2.00, because remember we're trying to express these all to 3 significant figures, so we're chopping off here, okay? Times 10 to the, we moved it 1, 2, 3, 4 places, and we moved it to the left. It's a big number, so positive 4 times 10 to the positive 4. Don't forget your unit, so make sure you write that gram there. And last but not least, 0.00012456 kilometers. Okay, so we're going to grab our decimal place. We're going to move it until we get a number between 1 and 10. Okay, so just behind the 1 there. And then we're going to write that number as 1.2456. Okay, we want to go ahead and round that to 3 digits. So let's go ahead and chop that off. 1.2, let's see, we're rounding up. Okay, round up, because you're dropping a 5. So greater than or equal to 5, you round up, times 10 to the 1, 2, 3, 4, and this time it's a negative 4. And that's because we moved it to the right. So we had a number that was small, and now we're expressing it as a number that's bigger, so the exponent is to the negative. Okay. All right. Number 2. Assume you are measuring the volume of a rock in the lab. You fill your large graduated cylinder with 9.5 milliliters of water. So V of water. I'm going to write that down. 9.5 milliliters. And then you carefully slide the rock into the water. The displaced water level now reads, so this is volume of water plus rock, now reads 18.8 milliliters. What is the volume of just the rock alone? So we're going to be subtracting the volume of water from the volume of water and rock to find out the volume of just the rock alone. So that's going to be 18.8 minus the 9.5. Okay, so we're going to get 9.3. Don't forget your units, milliliters. Okay, and notice because we're subtracting, we're going to apply the rule for adding and subtracting, which is to keep the same number of decimal places as there are in the digit in the measurement with the fewest. So they each went out to the 10th, so we're going to stay out to the 10th as well. All right, number 3. In the lab, you measure the length, width, and height of a wooden block as 2.1 centimeters, 2.9 centimeters, and 2.5 centimeters respectively. What is the volume of this wooden block? So the volume is the length times the width times the height. So we're doing a multiplication here. So 2.1 centimeters times 2.9 centimeters times 2.5 centimeters. I'm going to pull out my calculator here. 2.1 times 2.9 times 2.5, and I get, I'm going to go ahead and write the full answer from my calculator, which remember, doesn't necessarily give you the right number of sig figs. Okay, and it's centimeters times centimeters times centimeters, so centimeters cubed. Okay, and now we're going to figure out our sig figs. So we had 2 sig figs, 2 sig figs, and 2 sig figs. We're multiplying, so our final answer should have the same number of sig figs as the measurement with the fewest. So 2 sig figs as well. We're going to round here. We're dropping a number that is less than 5, so we're going to round down. Okay, so we're going to keep that as 15 centimeters cubed. Okay. All right, so we've got a lot of work there on the board. Let's go ahead and erase all this before we go on to number 4. All right, number 4. The mass of a chunk of sulfur is 3.05 grams. If the density of the sulfur is 2.07 grams per centimeters cubed, what is the volume? So V is our question. What is the volume of this sulfur chunk? Okay. All right, so this is not just a simple plug in for D equals M over V, because we're not solving for density here. We're given the density. We want to solve for volume. Okay, so we need to rearrange this equation and solve it for V. Okay, so we're going to do that by multiplying both sides by V so that it cancels out over here. We get V times D equals M. We're going to get V by itself, so we're going to divide both sides by D to get V equals M over D. And now we're ready to plug in the mass and the density and solve for the volume. Okay, so let's go ahead and do that here. The mass is the 3.05 grams. And the density is the 2.07 grams per centimeters cubed. Okay, so to help you keep track of those units and to prove to you that the grams will cancel out, I'm going to treat the numerator and the denominator as if they're both fractions. Okay, so I'm going to write 3.05 grams over 1 divided by 2.07 grams per 1 centimeter cubed. Okay, so remember when you're dividing fractions that you take the reciprocal of the denominator and you multiply the two, numerator and the denominator, together. Okay, so we're going to flip this. So the 1 centimeter cubed is going to be on top, and the 2.07 grams on the bottom. And so now you can really see that your grams are going to cancel out. And I hope that I've just proved to you by doing that that your final answer is going to have units of centimeters cubed. Does that make sense for volume? Absolutely. Centimeters cubed is an appropriate unit for volume, so we're on the right track for sure. All right, so let's go ahead and plug into our calculator the 3.05 divided by the 2.07. Okay, and we're going to get, again, I'm going to write the unrounded number first, 1.473429952 centimeters cubed. We've got 3 sig figs and 3 sig figs, and we're doing a division. Okay, so multiplying and dividing, you're going to keep the same number of sig figs as there are in the measurement with the fewest, so we're going to keep 3 sig figs. So our final answer is 1.47, rounding down, right? Round down, because this number to be dropped is less than 5. And don't forget your units, which you took great pains to prove would be centimeters cubed. So let me circle the final answer there. Okay. All right, I used up a lot of space, so let's go ahead and erase this one and go on to number 5. All right, number 5. Write a conversion factor that could be used to convert meters into millimeters. So we're just simply writing a conversion factor between meters and millimeters. So remember, milli means 1,000th, so it would take 1,000 millimeters to equal 1 meter. Okay, so that's one of a few different ways that you could write that conversion factor. 1,000 millimeters to 1 meter, or 1 meter to 1,000 millimeters. Okay, number 6, write a conversion factor that could be used to convert kilometers into miles. This is not a metric to metric conversion, so if you need to look that up, that's okay. Again, unless your instructor wants you to memorize that conversion factor, then you should memorize it. So in 1 mile, there are 1.609 kilometers. All right, and you could write it the other way as well. That'd be okay. Okay, number 7. Write a conversion factor that could be used to convert milligrams into grams. Okay. All right, so milligrams to grams, so 1,000 milligrams to 1 gram. Okay. All right, and number 8. So now number 8, 9, and 10, we're actually going to be using these conversion factors that we just wrote to solve some problems. So number 8, let's write it up here. The speed limit on the road in Canada is 95 kilometers per hour. Express this in miles per hour. Okay, so we're going to be converting kilometers into miles. We're not going to be doing anything with the hours. Okay, we're going to leave it in miles per hour, so we're not changing the units on the denominator here. All right, so it's a one-step problem. We've already got a conversion factor written here that we can use. Remember to set it up so that the kilometers will cancel out. So the 1.609 kilometers will go on the bottom, and the 1 mile will go on the top. Given cancels, desired does not. So now our final answer is miles per hour. And let's grab our calculator. 95 divided by 1.609. We get, unrounded, 59.0428838 miles per hour. I'm going to round that to 2. So we're going to get 59 miles per hour. Circle my final answer there. We rounded down because we were dropping a number that was less than 5. All right. Number 9. Let's do that one right here. The diameter of a red blood cell is 6 times 10 to the negative 6 meters. How many millimeters is this? Question millimeters. Okay. All right, so you can see that we already have a conversion factor from number 5 that will help us with this problem. I did that on purpose. All right, so let's go ahead and set this one up. 6 times 10 to the negative 6 meters. Putting the meters on the bottom, 1 meter, so that they cancel, and putting the 1,000 millimeters on the top. Okay. All right, so you can pull out your calculator here, but since we're just multiplying by 1,000, I'm just going to go ahead and move my decimal place 3 positions. Okay, so I'm going to get 6 times 10 to the negative 3 millimeters for my final answer. Okay. Okay, that was 9. Okay, so we're on number 10. Let's do number 10 right down here. You know, it might be a little bit longer of a problem, so I'm gonna scoot over a little bit and do it right here. Number 10. Number 10, a patient has a blood glucose level of 85 milligrams per deciliter. Express this in grams per milliliter. Okay, so how many grams per milliliter is that? All right, so this one is a little bit more challenging because we're going to be converting the numerator, milligrams, into grams, and the denominator, the deciliters, into milliliters. Okay, so let's just start with the numerator first because we've seen that before. That part's pretty easy for us. So 85 milligrams per deciliter. Okay, just focus on the numerator. So we're going to put the milligram on the bottom and the gram on the top. So there's 1,000 milligrams in 1 gram. Okay, and let's go ahead and solve that. 0.085 grams per deciliter. Okay, so I knew I was dividing by 1,000, so I just moved my decimal place 1, 2, 3 and got the 0.085 grams per deciliter. Now let's focus on the deciliters. Let's turn that into milliliters. There's a couple different ways you could do this. I'm going to do it the long way, where you go through the base unit, which is the liter, but you don't have to go through the base unit. You could just write a conversion factor directly that relates deciliters to milliliters. I find that to be a little bit more challenging, and I distinctly remember when I was new to chemistry, I always went through the base unit. So I'm going to show it that way for this problem set. All right, so we want our deciliters to cancel out, so I'm going to put deciliter on the top. There are 10 deciliters in 1 liter. Okay, so now I've converted to grams per liter, but I want it in grams per milliliter. So this is going to be a 2-step problem going through the base unit liter. And now I'm going to put the 1 liter on the top and 1,000 milliliters on the bottom. Okay, so we're timesing by 10, so that gives me the 0.85, and then I'm dividing by 1,000, so that's going to bring my decimal place over, so 0.00085 grams per milliliter. If you want to write that in scientific notation, it would be 8.5 times 10 to the -4 grams per milliliter. Okay. All right, let's go ahead and circle that. Okay, just real quick before we go on, what I was saying here about going through the base unit caused me to do this in 2 steps here, to convert the deciliters into milliliters in 2 steps. If you wanted to do this in 1 step, you could combine these 2 conversion factors, and you could say that in 1 deciliter, there are 100 milliliters. Okay, so then you'd be doing that in 1 fewer step. But I personally think that that's a little bit more challenging, especially when you're new to these kinds of problems. Okay, so if you need to do it in 2 steps to make sure you do it right, I think that's a small price to pay. It's a little extra time to get the answer right. All right, another thing I want to say really quickly before we go on, I know that this problem asks you to convert to grams per milliliter, but what if it said to convert to grams per centimeters cubed? I just want to kind of remind you real quick here of something we learned in tutorial number 1. Remember that a centimeter cubed is equal to a milliliter. So saying 8.5 times 10 to the -4 grams per centimeters cubed would be the same thing. So if it asked you to convert to cubic centimeters, hopefully you could do that easily, because you could get it into milliliters, and you know that there's 1 milliliter to 1 centimeters cubed. Okay, let's erase all this. Number 11. A hydrogen atom has a volume of 6.2 times 10 to the -31st meters cubed. What is this volume in centimeters cubed? Okay, so converting to centimeters cubed. All right, so we need a conversion factor here. For meters to centimeters. And actually we already wrote one above. Oh, I lied. No, we didn't write one, but we can write one. We know how to do that. In 1 meter, there are 100 centimeters. Okay? Now we want it to be cubed. So we're going to cube this to get meters cubed, which means that we also have to cube the numerator. Okay? So our meters cubed will cancel out. Okay? So we're multiplying by 100 times 100 times 100, 100 cubed. So that's going to be 1 times 10 to the 6th centimeters cubed. Okay, so I want to just remind you a little bit of some of your really old math that you may or may not have forgotten. Okay, when you are multiplying two numbers and they both have exponents, the exponents add together. Okay, if you were dividing two numbers and those numbers both had exponents, you could subtract the exponents to find your answer, the exponent for your answer. Okay, so we're multiplying here. So I'm going to add negative 31 plus 6. I get negative 25 for the exponent. And this works out really well for you if you have an instructor who won't give you a calculator on an exam, okay? Because they would expect you to be able to do 6.2 times 1, right? 1 times 10 to the 6th here, which will be 6.2. And then they might expect you to know how to handle those exponents too. If you're multiplying, you just add them together. Negative 31 plus 6, we get negative 25 centimeters cubed. If you were dividing them, you would then subtract them. Okay. Okay. Oh, let's circle that answer. Sorry. Circle the answer. There we go. Okay. That concludes problem set number 2. I hope that you've learned a little something and solidified your knowledge from tutorial number 2. And I certainly hope that you will consider tuning in to tutorial number 3. Thank you very much.